These two sky photos were taken less than an hour apart. Play Spot the Difference and you'll notice that some bright dots disappeared. Before you think, oh, stars do that sometimes. Spoiler, they don't. This looks more like a human-made spacecraft passing through the shot. But here's the twist. The photos were taken in 1952, and that's 5 years before we even launched our first object into space. So, what are those dots? Could they be signs of artificial objects made by extraterrestrials? Well, yes, they could. At least that's one of the hypotheses proposed by researcher Beatriz Villarroel at Stockholm University in Sweden. She recently published 2 papers trying to explain these disappearing points of light in photos from the early 1950s, what her team calls transients. So, these are star-like objects of unknown origin that showed up in the first Palomar Observatory sky survey. This was a major astronomy project in California that used a nearly 50-inch telescope that produced almost 2,000 photographic plates of the northern night sky. And there's no denying it, the transients were there. And they were acting weird, disappearing all of a sudden. So scientists had to find an explanation, and that brings us to 4 big hypotheses about what they actually are. Hypothesis number 1. Stars. This is a cool theory because we can actually test it. Go outside tonight and look at the stars. Pay attention to where they are in the sky. Then check again tomorrow night. You might notice that a few stars seem to disappear. But they didn't vanish forever, they're just harder to see. They can get washed out by normal stuff like clouds, haze, humidity, or even bright moonlight. All of that can hide stars from your view for a while, but they'll show up again eventually. So could those transients from the 50s have been stars, and the survey just caught a moment where they seemed to disappear for a sec? You see, astronomers have plenty of things in the sky that look like they vanish. For example, variable stars, whose brightness goes up and down. You've also got supernovae, passing asteroids, and active galaxies that can flare and fade. These changes can happen over minutes, days, or even years. But here's the problem. These transients don't really behave like that. In the old plates, they show up once, and then they're completely missing from images taken both before and after that. I mean, astronomers didn't see them on a blue sensitive plate taken just 30 minutes earlier. They didn't show up on a red sensitive plate taken 6 days later either. Whatever these things were, they were strange because there were so many of them and they were gone so fast. One moment they're there and then they never show up again. That's really odd. So no, they probably weren't stars. What seems more likely is that these flashes were sunlight reflecting off objects orbiting Earth. And that brings us to hypothesis number 2. They were satellites, or some other human-made spacecraft. You've got to remember, this was the 1950s, right when the space race was starting to take over headlines around the world. Everyone wanted to reach space, and they wanted to do it fast. So it's fair to ask, could this have been some kind of early satellite? And the answer is no. The Palomar survey plates were taken before the launch of the first artificial satellite, Sputnik, in 1957, so the timing doesn't really work, and that makes the human-made object theory pretty hard to support. Which brings us to hypothesis number 3, extraterrestrial objects. Yep. Something like an aircraft or a satellite, but made by a highly advanced civilization out there. Something that could have been flying around back then, maybe even watching us, and then for some reason never landed on Earth. It's a wild theory. But when you look at how strange these transients are, you can see why some people take this idea seriously. One thing I didn't tell you is that not all the bright dots were perfect little circles. Sometimes they showed up as straight lines or thin bands. Other times they looked sharp, almost star-shaped. And here's the weird part. Patterns like that can happen when light reflects off something with a flat surface. A regular space rock like an asteroid usually wouldn't have flat, manufactured-looking faces like that. So the study raises the possibility that something artificial might have been up there before humans even started launching spacecraft. And here's where it gets even stranger. These transients showed up around the same time as a bunch of old reports of strange objects in the sky. That same number in 1952, and a lot of people claimed they saw unusual flying objects over Washington, D.C. And it wasn't just one or two sightings. The US Air Force recorded a total of 717 reports during that period. That's a pretty wild coincidence, but extraterrestrial tech might not be the final answer. Some scientists lean toward a fourth hypothesis: human experiments. These newer studies suggest there could be a link to things happening down on Earth. In fact, more than half of the transients showed up the day after nuclear tests. One idea is that the flashes could have been debris from those tests getting thrown high up into the atmosphere. But this theory isn't perfect either. The transients left streaks on the images during the 50-minute exposure. And for that to make sense, the debris would have to stick around and stay concentrated in roughly the same spot for about 24 hours to match what we see. That's really hard to believe, if not basically impossible. Out in space, something doesn't stay fixed over one location for a full day unless it's being actively controlled. So for now, scientists still need more evidence before this can be the main explanation. Well, it kind of feels like we're out of hypotheses, right? And now you see why these transients are still such a big mystery. But there's a group of scientists who think the explanation might be way simpler than it sounds. They think it could all come down to a bad photo. I know, that's not exactly thrilling, but hear me out. We're talking about old images from the 1950s. And you don't have to be an expert to know that back then, sky photos were nothing like what we can capture today. These images were recorded on photographic plates. Basically, they were glass plates coated with a light-sensitive layer, used long before digital cameras to capture the night sky. For their time, it was a big deal. It meant astronomers could store what they saw instead of drawing it by hand. But those plates had problems. They were sensitive, they could get damaged, and the images weren't nearly as clean as what we get with modern digital sensors. These plates can have issues like scratches and tiny defects in the light-sensitive coating. The digitizing process can also add things that weren't really supposed to be in the image. Suddenly, you're seeing a bright dot that could actually be, I don't know, saliva? It turns out humidity can leave marks on photographic plates too. And if a scientist sneezed near a plate at some point, for example, that could have left a weird trace in the image. So if someone handled them badly decades ago, that could leave odd traces in the image. And researchers point out that some of the faintest transients show up in areas of the plates that look contaminated. To completely rule out this hypothesis, they need to inspect the original plates under a microscope. The problem is, the researchers don't have access to the originals. They're working with digitized copies. Still, Villarroel isn't fully convinced it's all just image errors. She says some of these transients line up in ways that are just too unlikely to be random. So the idea now is to keep digging into this with a project called ExoProbe. The goal of the program is to build a network of telescopes that will scan the sky for quick, sudden flashes of light. And if these transients are real, we might not have to wait much longer to find out.
Dozens of spacecraft and hundreds of probes take off from Earth and head for our planet's twin sister, Venus. It's about the same size as the Earth and has around 80% of our planet's mass. The temperatures here are too high for humans, and it doesn't have the air we're used to breathing. But we went there because scientists recently found traces of phosphine gas, which suggests that life might be there. Phosphine comes from various microbes and bacteria, so humanity goes on this journey to discover this life. With our technology, a flight to Venus would take 3.5 to 6.5 months, but we finally made it. Spaceships are landing on the planet, and when the first humans come to the surface, they see heat-scorched deserts, lava lakes, and geysers of poisonous acid. And that's it. Scientists miscalculated the radio telescope data. Phosphine never existed on Venus. So we're going back to the rockets, and we're getting ready for a longer trip across our galaxy. The scientists believe that there's at least 36 civilizations in the Milky Way that are similar to ours. They could be living organisms completely different from us. They may have different bodies, different eyes. They may walk and talk in a very different way than we do. But an advanced civilization has several criteria: technological progress and the use of developed communication between individuals. So, these civilizations must explore space, build cities, and be able to communicate with each other as independent species. Let's look at our galaxy and find these civilized worlds. So, the Milky Way is a spiral of 100,000 light years from side to side. If a star is born at one end of it in a super powerful blast, the light from that event won't even reach the other end until 100,000 years later. There's about 100 billion stars, and near each of them, there may be worlds similar to our solar system. Let's try to find these habitable worlds using giant sieves. First, we look for stars that have a lot of iron. Such stars burn at the perfect temperature for the development of life. And the iron in the star system will help form the cores of planets that will be home to another civilization. We sift the Milky Way through our sieve. We see that there are too many stars that fit the description, so we need another filter. Now let's find stars that look like the Sun in this pile. The star must be about 100 times larger than the Earth and 333,000 times heavier. An important criterion is the age of the star. When a star gets old, it begins to expand and turns into a red giant. At this time, it can absorb the planets around it. The life of such a star can end with a huge blast that destroys everything around it. So the star we're looking for must be relatively young. Let's use our sieve again. There's fewer stars, but still that's a lot. Now let's focus on the planets. They should be in the habitable zone of the star. Not too close to a star because then the temperature would be too high for life to be born. And not too far away. Then the planet would just be an ice block with nothing living on it. The temperature of the planet must allow the water to remain liquid. Another filter is the age of the candidate planet. It takes time for an advanced civilization to develop. Based on the experience of Earth, scientists believe that it takes at least 4.5 billion years for any life form to evolve to the human level. So we're looking for planets similar to Earth or older. We use our sieve one last time, and voila! We have 36 worlds where an advanced civilization is possible. Scientists conducted this study and published it in April 2020, based on these very criteria. All that's left is to discover these civilizations and make the first contact. We can detect such a civilization by using radio waves that come from it. Suppose there's a planet A with primitive living organisms on it. Millions of years of evolution, and they'll become a civilization with advanced technology. Radio waves will be the way they communicate. Then the whole planet will emit radio waves like a star emits light. And here on Earth, we'll be able to pick up this signal with antennas pointed into space. But there's a problem with the distance between the planets. For example, planet A is 1,000 light years away from the Earth. When planet A starts emitting radio waves, these signals won't reach us until 10 centuries later. We learned to emit and receive radio waves in 1895. And if the civilization on planet A emitted a radio signal at the same time, we won't be able to pick up that signal until 2895. It'll be the same on planet A. We sent a message in the form of a radio signal into space in 1974. In this signal, we encoded our number system, human DNA, and information about our solar system. If there's an advanced civilization on planet A, they'll be able to receive this signal only in 2974. And we'd have to wait another millennium to get a response from them. Another problem with radio waves is that they don't look like a constant glow on the planet, but like a flare. Radio waves are only used at a certain stage of civilization. At first, it's the primary method of communication, but then we begin to use cell phones, cable TV, and fiber optics. And as technology advances further, our radio wave light begins to fade out. So we only have about 100 years of active radio use by civilization to find it. One day we caught a strange radio signal of an unknown origin. Its characteristics suggested that the signal was created artificially, perhaps by an outer space civilization or a passing starship. Further searches for this signal given no results, and this gave rise to many theories and arguments as to what it really was. It could have been a signal from Earth that reflected off a satellite flying through the sky, or it could have been the traces of a comet a few light years away. But let's assume it was a civilization from outer space, one of those 36 that probably exist. Now we need to make contact with them. So we throw our luggage into a rocket and head out in the direction of our suspected planet. Our rockets can fly at 17,600 miles per hour. That means a rocket could cross the entire United States in just 8 minutes. But even if an advanced civilization lived near our closest star, Proxima Centauri, it would take us about 73,000 years to get there. Even at the speed of light, it would take 4.2 years, so we need to solve the problem of space travel. Our scientists plan to reach about a quarter of the speed of light with a laser. A powerful laser beam from Earth will push a microscopic probe in the right direction. This probe could reach our destination in about 17 years. And in another 4 years, when the signal from it reaches Earth, we'll know if there's an advanced civilization. Another possibility for faster-than-light travel is the warp bubble spacecraft. The spacecraft would have to compress space in front of it and stretch it behind its tail. Then we'll be able to reach any point in the universe in literally a few seconds. But such travel remains a fantasy for us. Perhaps we can get to different corners of the universe through wormholes. They're shortcuts similar to tunnels, but there's one problem. These wormholes might be inside black holes. They're the most mysterious objects in the universe. They're so heavy that even light can't escape their trap. Our spaceships wouldn't stand the tension either. There's also a theory that Earth is unique because it was born under completely accidental circumstances. 4.5 billion years ago, our planet was a block of lava that began to cool and solidify. But its tranquility was broken by an asteroid the size of an entire planet flying by. The collision occurred at such an angle that the Earth was not completely destroyed, but part of the asteroid remained in our orbit. A heavy rock near our planet stabilized Earth's rotation, and the gravitational interaction with the giant debris caused our core to heat up. In addition, the asteroid brought a lot of water to Earth. Such a collision is extremely unlikely. It's like winning the lottery, many times in a row. But so far, we have no reason to believe life in outer space exists. Just as we have no reason to believe that there's no advanced civilizations in the universe, except for ours.
It's 3 a.m. Suddenly, a radio telescope beeps. The monitor shows a violent, massive burst of energy where it shouldn't be. The scientist spills his coffee, scrambles to hit record, and zooms in on the source, but finds nothing. Just silence. Was this a glitch or some cosmic coincidence? Actually, new research argues that this is exactly what first contact might look like. Science fiction has been preparing us for meeting ETs for decades. Since we can't travel through space yet, we kind of hope they'll come to us. Hopefully in peace without the laser weapons. But astronomers shrug and say this is highly unlikely. So they've built better telescopes and asked a better question. If life exists out there, what would actually jump out on our screens? That brings us to the streetlight effect. It's the simple idea of searching for your lost keys under the lamppost, just because that's where it's easiest to see. Scientists do the same thing with the universe. They catch the stuff that's easiest to detect, not what's most common. This is how the first planets outside our solar system were discovered in 1992. For years, astronomers stared at sun-like stars, hunting for Earth-like planets, and found nothing. Instead, the first exoplanets showed up orbiting a pulsar. When a giant star runs out of fuel, its core gets squeezed into an incredibly dense chunk of matter that spins unbelievably fast. When rotating, it can aim a radio beam our way like a space lighthouse. Every time the beam crosses Earth, we detect it like a pulse. Thump, thump, thump. That's why it got the name pulsar. Turns out it was just spinning, but we kept the name. The timing of pulses stays so precise that it works like a cosmic stopwatch. So when a nearby planet tugs on a pulsar, that perfect timing wobbles. The pulses might arrive a bit too early or a bit too late. That's how astronomers found the surrounding planets. That's the streetlight effect on a cosmic scale. The idea is that we will only notice intelligent life if it does something loud that sets off alarms or breaks some rules. A Columbia astrophysicist named David Kipping gave the idea a name, the eschaton hypothesis. Eschaton comes from Greek and points to the end, like the final chapter. The idea is that when we finally find signs of intelligent life out there, it probably won't be during peaceful times. It will be because something went wrong. Some one-of-a-kind situation for them. A moment so loud it rips through the background static of the universe and reaches all the way over here. Common civilizations don't show up on radar. A world that runs on clean energy and keeps its tech quiet could last a million years, and we'd never know it was there. But what if they did something big and messy just to survive? Maybe they fired up a planet-wide laser array to nudge an incoming asteroid off course. Or maybe they're testing some super advanced technology. Whatever the noise, even if it lasts for just a few seconds, it could hit radio dishes across the galaxy like a flare. Yes, all of that sounds like science fiction, but that's exactly why we'd notice it. But here's an interesting question. Have we already detected such a signal? There is one candidate that fits this profile perfectly. It remains the most famous unsolved mystery in the history of the search for extraterrestrial intelligence. In 1977, Ohio's Big Ear Telescope caught a radio surge about 30 times stronger than the background, and a volunteer spotted it in the printout. He highlighted the signal's intensity reading, 6EQUJ5, and scribbled down "Wow" next to it, which is how the event got its popular name. The signal lasted exactly 72 seconds. This duration is significant because it matched the time it took for the Earth's rotation to scan across that specific point in the sky. The signal didn't fade away. The telescope simply looked past it. However, when astronomers returned to that spot, nothing was there. They've listened for nearly 50 years, but the signal never repeated. In the science world, things that can't be repeated usually get tossed aside as mistakes. It's important to be careful because false alarms happen pretty often. There's a famous false alarm that still makes astronomers cringe. At the Parkes Observatory in Australia, telescopes kept picking up weird, chirpy signals starting in the late 90s. For 17 years, nobody could figure them out. People blamed lightning, space weather, and space invaders. But in 2015, they all figured it out. The strange signal was coming from the microwave in the break room. If a hungry scientist pulled the door open before the timer hit 0, it leaked a tiny burst of radio waves that looked exactly like a signal from deep space. 17 years of mystery for a disappointing reveal. But the WOW signal didn't behave like that. It didn't look like a satellite, a plane, or any kind of interference, and they definitely made sure it wasn't a kitchen appliance. It came from deep space, near the constellation of Sagittarius. If we apply Kipping's eschaton theory, this might be what we need to prove life outside our planet. The WOW signal could have been an engine flare from a colony ship trying to escape a disappearing world. Or it could have been a rare natural radio event that just happened to hit us at the perfect moment. The WOW signal grabbed attention because it reached us in radio waves. But Kipping's theory also asks, what if a civilization gives itself away in a completely different way, not with sound, but with pollution? Clues that technology, not nature, caused something are called techno-signatures. Think of them as leftover traces. If you walk into a house that smells of fresh paint, you can assume someone was there recently. Astronomers use the same logic with planets. They scan distant exoplanet atmospheres for chemicals that shouldn't exist naturally. The biggest target is a family of chemicals called CFCs. For decades, humans filled the air with these gases because they were cheap and useful. We used them in spray cans and cooling systems, until scientists realized they were bad for the ozone layer. That's why CFCs are such a big deal. Nature doesn't make them. These chemicals are 100% artificial. So if we point a telescope at a distant planet and find its air is full of CFCs, it would be the vital clue astronomers have been waiting for. It could mean someone intelligent is down there, and they're polluting their world on an industrial scale. Besides radio waves and chemistry, you might be able to spot a civilization if they're doing something cool with light. In 2015, astronomers watching a star about 1,400 light-years away, nicknamed Tabby Star, noticed something that seemed impossible. When a Jupiter-sized planet crosses a star, it blocks about 1% of the light. But this star suddenly dimmed by 22%, and it wasn't one clean dip either. The brightness kept plunging in weird uneven chunks with no tidy, repeatable schedule. that's something huge getting in the way. For a brief moment, scientists hoped for a Dyson swarm. That's a hypothetical megastructure made of solar panels and wrapped around a star to capture its energy. Sadly, later studies leaned toward dust clouds instead, but Tabby's star still grabs attention. We keep asking, where is everybody? But for decades, we could only watch a tiny slice of the sky at a time. That's about to change with telescopes like the Rubin Observatory that will sweep the entire southern sky every few nights, over and over, like a giant security camera for the universe. If something flickers, flashes, or suddenly vanishes, we won't just get one blurry screenshot, we'll have the replay. Finally, what if we are the loud ones? We tend to think Earth is noisy because of our TV shows and music, but those signals fade fast. Our real scream is planetary radar. We blast massive radio beams into space to map asteroids. Some researchers estimate that these shouts could be detected from as far as 12,000 light-years away. That's very far, but in space terms, it isn't even the backyard. If we really want to get someone's attention, we need to get way louder. Comet 3I Atlas crashes into Earth, and a wave of widespread destruction starts shaking our planet. Ginormous tsunamis are swallowing coastlines, devastating earthquakes are cracking the ground. Hot debris is igniting massive firestorms. Thick clouds of dust are blocking the sun. Now, that's what could happen if 3I Atlas, a massive comet traveling through the solar system, collided with our planet. But can this disaster actually occur? When will 3I Atlas be the closest to Earth? Let's figure this out. First of all, this comet turned out to be way larger than we previously thought. Its weight is likely a whopping 33 billion tons. Let's throw in a few comparisons to put it into perspective. The Eiffel Tower weighs about 10,000 tons. So, 33 billion tons is roughly the weight of 3.3 million Eiffel Towers. Impressive. Next, all the cars on Earth, and we're talking about 1.5 billion vehicles, each weighing about 1.5 tons, weigh approximately 2.25 billion tons. This means that the comet's mass is 15 times greater than the combined weight of literally all the cars on the planet. And finally, compared to buildings on Earth, 33 billion tons is equal to several large metropolitan areas made entirely of steel and concrete. But the whole idea of how big this comet is fades in comparison with an even crazier fact about it. It could be unknown technology from a different galaxy, and some experts are somewhat sure about that. But why? 3I Atlas was first spotted in July by NASA's Asteroid Terrestrial Impact Last Alert System. A bit later, the US Space Agency confirmed that the object was an interstellar object, only the third we have found so far. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But the newest comet, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which is just a quarter-mile long, and Borisov, which is about 0.6 miles across. By the way, some believe that the comet could be even bigger, up to almost 7 miles, but scientists haven't found any proof of that yet. Besides its size, 3I Atlas is different in other ways too, which makes some scientists question its origins. The object is shedding huge amounts of carbon dioxide and dust while zooming towards the sun. It's most likely the proof that 3I Atlas is more massive than the other two interstellar objects by 3 to 5 orders of magnitude, which is basically a serious anomaly. The comet is also traveling toward the sun incredibly fast. We're talking about around 130,000 miles per hour, which is almost 170 times the speed of sound. Another weird thing is that this interstellar object is following a straight trajectory, unlike anything else in the solar system. Most space bodies move along curved orbits due to the force of gravity. That made some researchers believe that 3i Atlas might be a probe sent by another civilization to explore Earth, possibly with not-so-friendly intentions. Their theory is that the object could be a technological artifact, a sign of cosmic intelligence. You see, the comet moves in a pretty weird way that doesn't totally line up with just gravity. Its trajectory also takes it close to Venus, Mars, and Jupiter. And researchers think that these planets might be especially interesting for another civilization to pass by. Another bizarre fact: the space traveler also spins backward compared to most stuff in our solar system. This might be necessary to make it easier for 3i Atlas to get near Earth without much resistance. Some scientists think the comet's odd spin and flight path could help whoever or whatever made it take super precise measurements of the planets, things like their orbits and sizes, to plan a perfect route through the solar system. If 3i Atlas suddenly changes direction in a big way, that might mean it's using some kind of built-in engine instead of just drifting through space. There's also another theory that suggests it could be a piece of unknown tech that's still active. There's no need to worry though, at least at the moment. The comet isn't coming anywhere near us. NASA says it'll stay around 150 million miles from Earth when heading toward the Sun. So the question is, where do such space visitors come from? Astronomers have found that the 3 interstellar objects we discovered came from totally different parts of the galaxy. And each of them has its own age and background. 3i Atlas turned out to be the oldest, about 4.6 billion years old, and it came from the Milky Way's thick disk. That's a region filled with older stars that have fewer heavy elements. 1i Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. Oumuamua, Hawaiian for a messenger from afar arriving first, was the first known object from another star system to pass through our solar system. Basically, the first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. It also sped up in a way that couldn't be explained by gravity alone. Changes in brightness showed it was tumbling end over end instead of spinning smoothly. At first, scientists were confused because the space body didn't have a tail or cloud of gas like a normal comet, even though it was accelerating. That led to a lot of debate about what it was made of and where it came from. Just like with 3i Atlas, some people wondered if it could be technology created by a space civilization. But most scientists now think Oumuamua was a totally natural object, just a really weird one. The best guess is that it was a comet releasing invisible hydrogen gas, which caused it to speed up slightly. Sadly, by the time astronomers found it, it was already heading out of the solar system, so there wasn't much time to study it. As for 2I Borisov, it sits in between at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. The comet was discovered in 2019 by Gennady Borisov, an amateur astronomer who actually built his own telescope to search for faint space objects. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma. That's a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the Sun. Plus, it boasted a long tail of dust and gas. Studying 2I Borisov helped researchers learn more about how other planetary systems form. Observations showed that its dust grains were compact and that the amount of gases like carbon dioxide changed a lot as it approached the Sun. It could mean that the comet formed under very different conditions than anything else in our solar system. Now, 2I Borisov is speeding away from the Sun and will never return. but it allowed scientists to take a unique glimpse into the chemistry and history of distant worlds. Interestingly, the differences between these three space objects suggest that interstellar visitors have been getting kicked out of planetary systems all across the galaxy for billions of years, so it's not something new. To figure out if 3I Atlas might be some kind of probe from another planet, scientists are checking for any signs of technology, like strange radio signals, electric activity, and weird movement patterns. If the comet suddenly changes course or drops smaller objects nearby, it might be our cue. But even though 3I Atlas is moving in a pretty wild and energetic way, it's most likely just a natural interstellar object passing through. Researchers say they'll need a lot more proof before anyone can seriously say the space wanderer was sent by someone from another planet. What do you think about this newly discovered space traveler? Share your opinion in the comments.